Audio Jungle. Audio Jungle.
So today, turning flight, that two things I had explained in last class, right? So those who have not attended, please watch recorded videos. And now, turning flight, we'll discuss. Check. We have to talk because load factor for the turning flight we had seen in last lecture. Now today we have to go for the calculation of the radius of turn. Okay, and for the radius of turn, I had drawn one diagram. If you check, basically this is the one figure what I had drawn in last class. So in short, again I will try to recall the things so that it will be easy to you to understand the topic. This is lift, this is weight. This is before turning. Okay, when the aircraft is what turned, fine. All right, here if you resolve the forces, so I explained perpendicular downward is weight always. This is lift. This is the vertical plane. So from the vertical plane, it is tilted by phi angle. Okay. So this component will be L cos phi. Obviously, this side one more component of the lift will come, horizontal component. This will be L sin phi. So because turning is what just like a circular motion, not exactly circular, but yes, it is arc. So definitely there will be the force. Circular motion, you had seen two types of forces acting. One is centripetal, another is centrifugal, but both magnitude wise it is same, right? So because center point is what here, this is the center. Okay, I will show another diagram also. So it is, this force is what away from the center, hence it is the centrifugal force mv square by r. Okay, this is what, this the both diagram. If you check, this is the front view for the aircraft. How top view will looks like? So top view will be like this only. Okay, and it is turning, so it will turn like this. This is the one kind of arc. Okay, the diagram is should be a one arc. So again I will show you. Okay, so have patience, I am drawing this. Anyway, we just say this is the turning. Okay, now if you check, so this is what, this is the one arc, and this is the angle which is called turning angle. This is what the O center. Okay, and this is nothing but radius of the turning. All right, this aircraft is what going to turn this side. Ah, so what is M? Mass of aircraft. What is R? Radius of turn. What is the V? That is nothing but speed of the aircraft, or given true air speed, you can say, or speed of the aircraft, okay, or velocity of the aircraft. What is phi? It is called banking angle. What is psi? It is turning angle. This is the center point, okay. So this is the information you need to know, okay. Three diagram we have. This is the figure 1, front view, figure 2, and this is the, you can say, this is the top view, okay, for the aircraft. So in top view only you can get turning angle psi, because it is making in horizontal plane, okay. But phi is the angle making in vertical plane. This is nothing but what? Vertical plane. So phi is what? Banking angle which is making from the vertical plane, and this is nothing but horizontal plane, okay. That psi is nothing but turning angle which is making in horizontal plane. All right. Yes, velocity of aircraft or speed of the aircraft. Fine. This is the diagram. From this diagram we have to work out, okay. If you know what is our job, our job is to get what is the radius of turn. So for the radius of turn, you just make one small heading, which is nothing but radius of turn or turning radius. So how to get this? Simple, because top view of the aircraft you have seen, it is like, see, this is what? Turning, yes or no? This is the turning. So from the horizontal plane, it is making angle psi. This is the center point, and this distance is nothing but r, which is called radius of turn, okay. You have to calculate radius of turn now. So what you will do, for the aircraft, you have seen that component, okay. What is the component? This is the horizontal force. Check this horizontal force here, yes or no? So for this aircraft, if you check, horizontal force is nothing but L sin phi. It is towards the center, and mv square by r, it is away from the center. So same thing you can draw here. I mean, you can show the horizontal forces, which is nothing but, this is what? Check, L sin phi, and here it is nothing but mv square by r. I mean, this aircraft is what? Just say this is the aircraft. You can say this is the aircraft, okay. Fine. So horizontal forces, L sin phi, which is nothing but lift component in horizontal, okay. And what is the mv square by r? It is centrifugal force. Okay, and centrifugal force is what? Away from center, and this force is what? Towards center. Yes or no? What we'll do, we'll equate these two forces. So what we'll get? Right, it is nothing but m. You can, if you want, you can write in terms of the weight also, otherwise not required. Okay, but like L sin phi, you know what is the value. Similarly, if you want, you can write the vertical component. So this is the equation number 1. Similarly, you can write the vertical forces balancing also. So what is the vertical force balance? Check. L cos phi is equal to W. So what is the vertical force? It is L cos phi is equal to W. All right. Now this is equation number 2. Okay, fine. That you can, like load factor we had discussed in last class. So even though here also you can write, but we had discussed, so no need to write again. Now we have to use this two equation and we'll simplify and we'll get R. Okay, what is that value? Check. Can I write mv square by R? Okay, W is equal to L sin phi by L cos phi. We can write, you just divide what you have done, equation 1 divided by equation 2. So what you will get? mv square by R. What is the W? W is the weight. What is the weight? Mass into gravitational acceleration is equal to tan phi. This is simple simplification only. What you will get? Tan phi is equal to mass cancel out. What you will get? V square by RG. Yes or no? What you have done? You just have taken two component of the, I mean horizontal and vertical component of the forces, and then you simply divide it. What you got? R is equal to V square by G tan phi. This is what? Radius of turn. Get question they had asked. V square by G tan phi. Okay, that is nothing but radius of turn. All the component you know. R is radius of turn, V is the velocity of the aircraft, G is a gravitational acceleration, tan phi is the banking area. All right, nice. Now if you want to write this radius of turn R in terms of load factor, this is the another point. Okay, so this is the first. What is the second? R in terms of load factor. How to write? What is the load factor? That load factor is nothing but N. is lift by weight. Check what is the lift by weight here from this equation. Lift by weight is nothing but what? 1 upon cos phi, which is nothing but sec phi. So right here, sec phi. Check tan phi and sec phi, any trigonometric relation? You know? Yes, there is the relation. What is the relation? We know 1 plus tan square phi is equal to sec square phi. Yes or no? What is tan phi then? Sec square phi minus 1 in root. Okay. What is the sec square phi? Sec square, check, n is equal to sec phi. So what is the sec square phi? It is n square minus 1. Yes or no? Because sec phi is nothing but n. That is load factor for the turning flight. Yes. So tan phi is equal to what? Root of n square minus 1. Now, what is the radius of turn? You got here r is equal to v square by tan phi is equal to v square by g root of n square minus 1. Okay, this is very important. Gate question they had asked, na? Sometimes in terms of load factor, sometimes in terms of banking. This is the formula of radius of turn in terms of banking angle, and this is the in terms of okay. So always remember this. This is very special for gate. Okay, question, gate question alternate. They are asking, sometimes they are asking in terms of banking angle, sometimes they are asking in terms of load factor. All right, this is very special formula. Hope you understood this. Yes or no? Fine. This should be very clear. Again, I must say, if someone have any kind of doubt, then can write comment message on comment box. So I will answer it. But I'm sure you may not get any kind of doubt. Whatever I'm explaining, you just listen carefully. Okay. Right. So this is very one important parameter called radius of turn or turn radius. Second is what? Second is nothing but time required to turn. Okay. Time required to turn. What time has been taken to turn the aircraft? Okay. R you have seen. Now we'll calculate the time required to turn the aircraft. Suppose any angle, they will tell you this is the angle, and for that you have to calculate the time. Okay. Third will be the rate of turn. So better we'll go for the rate of turn first. Okay, then we'll go for the time required to turn. So what is the next? And different like for the same turning flight, different parameters I'm telling you, explaining you, and believe me, all the parameters based question they have asked. Okay, so third one is the rate of turn. Yes or no? This is very basic. And rate of turn is nothing but omega, because it's the angular velocity, right? See, I mean, how it is like, see, suppose this is the circular motion. Just think in this way. So it, any I mean partial part you can take. Suppose aircraft is what here, anywhere you can take. Suppose aircraft is what here, check. Okay, this is the aircraft. This is the aircraft. This is the aircraft. Hmm? Or you can take this here. Huh? Any position you can take. I'm just considering this diagram. So basically it's a circular motion. I mean, if you take this part, so diagram will be like this. Partial image you have to take that time. No, I must say this. Check. So it will be like check. This is the aircraft. Is like this is psi, and this aircraft here velocity is nothing but velocity of the aircraft v. This is the radius turn, and angular velocity omega, which is called rate of turn. Okay, which is called rate of turn. All right, rate of turn. Now check. So how to get angular velocity? It's a 12th standard physics only. No, there should not be any doubt. So what is the angular velocity? Angular velocity is nothing but rate of turn here. All right. So you know the formula v is equal to r omega. What is the omega? It is omega. Okay. What is omega? V by r. You can say v is the linear velocity that of the aircraft, and omega is the angular velocity. You know that, right? Simple formula. Linear velocity divided by radius. You know that formula you had seen many times in physics, no? 9th standard, 10th standard physics you had seen. So what is the rate of turn? So question based on rate of turn they had asked, okay, in your exam. Rate of turn, that is omega. Omega is nothing but v by r. V as it is, what is r? Just now you have calculated r, v square by g tan phi. Okay. Is equal to, in terms of n, it is nothing but this is the formula. Yes. So this separately you can write. Okay. This is very important, very, very important. In GATE they had asked. So this formula you can write g tan phi, this one will be cancelled out, by v is equal to divided by p. This is the formula. Okay. What will be the unit? Obviously radian per second. There should not be any doubt. This is the important formula. You make it star, na? Or make, you just keep this formula in box. Okay, this is very important, star, na? And this is important for gate. Based on this formula also gate question they have asked, not one time, many times. Okay. Fine. This is the third one, I think. No? Third, yes. What is the four? Four is time required to turn. Time taken, time required or time taken, time taken or time required to turn. Same thing. Very simple. What you will do? Where is your aircraft? This is your aircraft. Top view I am showing you. Okay. It is going to turn. What angle it is going to turn? Psi angle, I must say. Okay. This is what center point. This is what radius of turn. Okay. And obviously horizontal forces, if you balance, this side force will be m square by r. That is not your concern. Concern is what? To calculate the time required to turn. How to calculate that? Okay. I will give the basic mathematics ninth standard concept here. This is what O, this is what P, and this is what R. So it is like, sorry, this is the angle, how much psi. This is the radius, how much R. This is the, okay, don't say this is R, PQ. Okay. This is the arc of the circle PQ. This is the center O. This is what? Arc. So arc is the one kind of circular distance. Okay. How to calculate this? You know, arc is equal to, for the circle, arc is equal to, what is the arc? It is nothing but, or you can say angle is equal to, because that you are habituated to remember. So I must say angle. What is the angle? Angle is nothing but arc divided by radius. We all know. What is the angle here? Psi. What is the arc? It is PQ divided by radius is what? R. Yes or no? So basically, what is the PQ? PQ is the arc, or you can say PQ is the arc, or you can say circular distance. Means in circular motion, during the turning, what distance that aircraft has traveled is nothing but PQ. All right. Now I will ask you, what is the velocity? Arc length, right? Yes. This is what? Arc length. Fine. Arc length. All right. So that is, arc length is nothing but basically it's a circular distance which is covered during the turning flight. No? So what is the velocity? Velocity is nothing but distance by time. Yes, what is the time? Time is nothing but distance divided by velocity. All right. Now, what is the distance? Distance is nothing but circular distance, which is nothing but PQ. It is nothing but PQ. What is the velocity? It is V. Velocity of the aircraft here. This is the V. V infinity or V simple say V. Okay. All terminology you know. V is the velocity of the aircraft. R is the radius of turn. Psi is the turning angle. So no need to write again and again. That should be clear. Okay. Fine. PQ by V. What is the PQ? Just now you have calculated psi into R. If you check what is the PQ, it is psi into R. You can write psi into R by V. Yes or no? So time is nothing but time required. It is nothing but psi by V into R. You know what is the R, radius of turn or turning radius. Psi by V into R. What is the R you have calculated? Check. R you have calculated is nothing but V square upon G tan phi. V square upon G tan phi. How much it is? It is psi by G divided by V into tan phi. Check. Psi by Z V into tan phi, or simply you can write time required to turn is nothing but time required to turn psi angle. To turn psi angle. What is the time required to turn psi angle? It is T, and it is nothing but psi V by tan phi, or you can write psi by V G. What is the tan phi? It is nothing but n square minus 1. No? So this should be very clear. Okay. Whatever the derivation I have done today, it is very important and it is asked in your gate. Not one time, I told you many times. And it is very simple derivation. Okay. If you practice 1 or 2 times, okay, then you will remember the formula. And don't uh, derive all every time. Okay. You just mug up all the formula. Whatever I'm deriving, you just write 2-3 times and mug up all the formulas. Because in examination, you may not have a time to derive the formula. Okay. That is very important part. Done.